Now moving on to question 6. We have this huge output, super scary looking and terrible, but it's really not. It's really not scary at all. Okay, so it's really not scary at all. So how it's set up is it shows you on the left, it shows you which two means are different. So we're doing some two-way ANOVA about chopstick length and let's see, chopstick length and the size of the chopstick itself, like the thickness of the chopstick, to see what's the best size chopstick thickness that is best for picking up things with chopsticks, food or whatever. Really kind of silly, asinine test. But we get this cool output. So we get all this big output, and so what they're doing is they're trying to compare different lengths. They're trying to find they have treatments. They have 6 treatments, so 6 different kinds of length, and they want to know which is the best, which gives you the best rating, which gives you the best picking up ability. This is a real study, by the way. Okay, so they give all these different treatment mean comparisons. We do like the second mean minus the first mean, third mean minus the first mean, 6th versus the second mean, 6th versus second, etc. So all the possible differences, and it gives you the difference in the means, and it gives you the Tukey HSD. Remember, we had y bar d plus or minus d plus or minus MSD. This is the Bonferroni correction. Well, there's another correction which you guys have heard about called the Tukey HSD, which stands for honest significant difference, and it's actually the best and smallest margin of error when you're comparing treatment means, like pairwise comparisons of treatment means. So that's what this is in here. Okay, so you're going to notice that they give you the difference in the lower and the upper bound after the HSD is factored in, and we want to know which ones are significant. Now this like kind of general statement on how to figure out if the treatment means are different remains the same even when HSD and MSD are changed. I'm sorry, when you change MSD into HSD. So if y bar d is greater in absolute value than HSD, that means there's a significant difference in the means. Okay, and if y bar d is less than HSD in absolute value, that implies there's not a significant difference. Okay, now all you have to do now, so in the corresponding confidence intervals, if y bar d is less than HSD, the confidence interval will include 0, because if you subtract and add HSD to it, it'll go beyond, or it'll go negative and then become positive because HSD is bigger than y bar d. Okay, so all you have to do is look at whether or not the confidence interval, the lower upper thing, has 1 positive and 1 negative, and you'll find that the intervals for, and there are 15 of them, it says on the far left which interval it is, and you'll find that for interval 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 13, 14, and 15, all of these intervals include 0. All of them. All of them go from negative to positive, or positive to or they all go from negative to positive. And that means that those y bar d's, those differences, were less than HSD in absolute value. Okay? But now if you look at intervals 10 and 12, they are only negative to negative. Or positive to positive. Nope, they're both negative to negative. Yeah, so they're both negative to negative. And since they didn't include 0, they didn't cross 0, that means that the difference is greater in absolute value than HSD. Right? Perfect. And you know that because these intervals included 0, these intervals did not include 0. So that's how you know that they're significantly different or not. So these are the ones that are significantly different. Okay, now, as just one more thing, because I saw some people getting confused about this. So we have 15 comparisons, right? 15 means they're compared. So as you can see from the second leftmost column, you have like 2 minus 1, 3 minus 1, 4 minus 1, etc. And the biggest thing that you have is you have 6 minus whatever. So this is the biggest number in that column. Okay? So that shows you that you have 6 treatment means that you're comparing. So you have 1, 2, 3, 4, 5, 6 treatment means to compare. Okay, and how do you find out how many treatment means are going to compare? Well, you do, and this is the general thing, you do 6, choose 2, okay? Because you're choosing 2 to compare out of 6. And that equals 6 times 6 minus 1 over 2, which equals 15. But 6 choose 2 also equals 6 factorial over 2 factorial times 4 factorial, or 6 minus 2 factorial is 4 factorial, which equals 6 times 5 times 4 times 3 times 2 times 1 equals 2 times 1 times 4 times 3 times 2 times 1. So these cancel out. This is just nothing. 3 equals 15. So these are the two things that answer that question. 6 choose 2. Now 5 choose 2 also answer that. That's also an answer to that question. So you have 5, 3, 2, 1 over 3, 2, 1 times 2. So nope, it actually doesn't. Never mind. 6 choose 2 is the only thing that answers that. So yeah, 6 choose 2. Remember that, because they're going to ask you how many comparisons can you make, and you're not going to know unless you know this equation, or r times r minus 1, which is r equals treatments over 2. 6 times 5 over 2 is 15. Okay, so just keep that straight as well. Don't be scared by all this output, because it's just, there might just be a lot of treatments, and most often in situations like that, most treatment means are not significantly different. So it's pretty easy after that.
The Teaching Center, UF's Learning Resource Center.